Today's topic is the electromagnetic induction numerical. Let's read the question first and see how to solve this. So you have two straight conducting plates forming an angle theta where their ends are joined. Okay, so I think these are the plates being referred to. The angle between them is this. Then there is a conducting bar in contact with the plates. So that's your conducting bar. And they form an isosceles triangle. So this side and this side are equal. With them starts at the vertex at t is equal to 0. Okay, so they start at t is equal to 0. Okay, which is the vertex, right? So this is at t is equal to 0 and moves with constant velocity v to the right. So they have shown the velocity with which this whole isosceles triangle moves. Now a magnetic field is pointing out of the page, which is B. Okay, you can see the B is coming out of the page. What is the magnitude of EMF induced at t is equal to 1 second? All right. So it is very clear as this whole triangle moves inside the magnetic field, an EMF will be induced, right? This is what we need to find out. So we know the formula of EMF is obviously minus d phi by dt, right? This is very standard. You can, you know this concept, right? So rate of change of flux with a negative sign. Now, what exactly is happening as it starts moving? You know, the area of the triangle, if you notice, right? If I draw a perpendicular from this place, right? What is the length of this particular, let's see, do they have the length of the, so this is an isosceles that is not known, angle is known. Let's say the length of this particular this part is L, right? So I'm referring to this is your L, and if I have to find the area of this triangle, right? If I have to find the area of this triangle, obviously it is going to be half base into height. If I know the theta is the angle which is there, and instead of assuming this to be L, let me assume that the angle, okay, so let this be L. This is your, so this is theta by 2, right? And this is the length of the conducting plate. Okay, so let's say, okay, so half base, which is, how much is this? Okay, let's say how much is this? If this is your hypotenuse, this is the angle, then this is L into sine theta by 2. This also is L sine theta by 2. So the total length is 2L sine theta by 2. So that's your base, right? Let's talk about height. So height, if this is the angle for this triangle, it is the base here, right? So your base is equal to L cos theta by 2. So half base 2L sine theta by 2 into L cos theta by 2. That's your situation. So 1, 2 will get cancelled and you will be left with L square sine theta by 2 cos theta by 2. I think there is no 2 available, right? So anyway, let us see how it goes on. That's your area. Right now, you know the rate of change of flux, you need to have a reason for the rate of change of flux to happen. Now, if you notice the conducting bar is in contact with plates, this is in contact with the plates and forming an isosceles triangle with them starts at the vertex and moves with constant velocity. So the bar, this particular bar is moving, okay? These two are not moving. They are fixed. So as the bar will move, if you notice the area of the triangle will continuously increase. So if the bar comes here, the area now you will sweep increases, right? So basically you're saying the change in area is responsible for the EMF inducement, right? So let's talk about that. So if I were to say, the EMF then actually is minus d by dt. And flux obviously is then b dot a, right? So b dot a. Now we know b is fixed, so I'm going to take my b out, and this becomes dA by dt, right? Now what is my area? My area is written like this. So I'm going to write EMF is equal to minus b. Let me take derivative of this and see if I'm able to make sense of it. I will get the answer as dA by dt is equal to, so this is the area, right? Half base into height. And what is changing? I think this L will change, right? Because the as this rod progresses, so if you have this diagram, the rod is here, right? So L is this, but if the rod reaches here, then the L changes. So it is the inclined length which is changing, right? So if I were to say why is the area changing, the area is changing because L is changing, right? So I will say, okay, d by dt, so L square sine theta 2 cos theta 2. Obviously, I'm not doing anything with the angle. So really makes no difference at all, right? So if I were to take the derivative, I will now get it as dl, right? So this will become 2l dl by dt, and this is sine theta by 2 cos theta by 2. Just ignore, it's just coming like that, so I'm just writing it. But you know what exactly is happening, right? So we have, if you see the answers, what we have is this velocity square. I think we have sine theta cos theta by 2. But what do we do with this, and how do we link this with the velocity? So if you notice, dl by dt is in this direction and velocity is in this direction, right? So this is your dl by dt. If I were to make this triangle, this is theta by 2. So dl by dt, which is your hypotenuse, can be written as what? So hypotenuse, and this is your base, by the way, right? The velocity with which this particular rod is moving. So dl by dt, which is your hypotenuse, and this is your base, right? So base upon hypotenuse. So I will write a v upon the hypotenuse is equal to cos theta by 2, right? So dl by dt actually becomes v upon cos theta by 2, right? So I already have a L here. So what I do is I write this as 2L, and then I write it as V upon cos theta by 2, right? Because my dl by dt in terms of velocity is this. So I've written 2L, I have written dl by dt into sine theta by 2 cos theta by 2. Now this gets cancelled. So I'm left with 2LV sine theta by 2. Still, I'm not getting any answer. I think we already have a B. So I have forgotten to write the B, which we will write in the end because we have to get the answer, right? So this is where we have reached so far. 2LV sine theta by 2. We still have assumed what is L. We don't know what is the length L, right? So how do we get the length L now? That is a question. We don't know L, but can we convert the L into some expression or not? Moves with constant velocity, right? So there is no L in the formula. If you notice, we also have expressions with sine theta by 2, which we have, but how do we get rid of L is a question. So area is equal to how much? Area is increasing. We have taken the derivative of the area and we have reached 2LV sine theta by 2. We have not been able to remove this L, which is an unknown quantity, right? So how do we approach this unknown quantity, right? So if this is your L, right, which is continuously increasing, this is your velocity. Okay, so what is the relationship between this length and this particular base, right? So this particular base we have written as B, right? So this is what we had used. Base is equal to 2L sine theta by 2. But we don't know the value of the base actually. So let's think through this. This is area. Area is half BH, so half length into breadth. Okay, understood. Nothing wrong. We have taken the correct things. Just that I think dA by dt is length square. But why this will not go away is my question, right? We need dA by dt for the EMF. So there was a bit of struggle and we were not able to eliminate this L. Okay, so if I read this question very carefully, what's happening is that this rod is starting at the vertex. Okay, and in 1 second it covers a certain distance, right? So this rod, if it is moving with a velocity v, in 1 second how much distance will it cover? V into 1, right? So this particular thing is v into 1 is equal to v. We have to find what is the corresponding L, because when the rod is there is no area. As it moves here, you can see the triangular area is increasing. So at t is equal to 1 second, this particular thing, x is equal to v into 1, right? So if I were to draw this triangle, this is my L, which is, I'm not able to remove my L, right? If you remember, we were able to reach here. What's happening is this L is not going away, right? We want to get rid of this L. So let's say this is L, this is V. What is the relationship between them? V by L, right, is equal to then cos of theta by 2, and L is equal to V upon cos theta by 2, right? So if you move through a distance of V meters horizontally, this particular length will correspond at that point at t is equal to 1, this, right? So your change in area, if I were to write, I'm referring to this expression, is 2 multiply by v upon cos theta by 2 into v, because dl by dt can be expressed in the form of what? This is not velocity actually. If you notice the relationship which I found out, which is this particular relationship, I can say that if I take the derivative of both the sides, so if this was x, right, then x upon this particular thing, right, is y is equal to, we have written it as cos theta by 2, right? So dx by dt, right, is the velocity, is equal to dy by dt into cos theta by 2. So this is your velocity, right? So this is v. This is basically dl by dt, right? So I'm going to substitute L as 2. So in the expression, I have to get rid of L. I have written L like this. I also need to get rid of this dl by dt, which is basically dy by dt, if you notice. So I'm going to write this as v upon, what should I write it as? This is dy by dt, right? So this is v upon cos theta by 2. So this is v upon cos theta by 2. And then this is sine theta by 2 and cos theta by 2, right? So this is the way it works. So 1 cos theta by 2 cancels. What you're left with is 2v square and tan theta by 2. Finally, I think we have some hope that we will be able to get. So we can see, so 2v square, and then of course, because you're calculating the EMF, and we started with minus b into dA by dt, right? So dA by dt we have calculated now as this expression. So we just need to multiply this with b to get the answer. So the correct answer is 2bv squared tan theta by 2. So I have just shown you how a typical student struggles to understand the problem. There can be elegant methods, but if you notice, there is a lot of dependence of this question on the knowledge of trigonometry and understanding the situation, right? Starting at the vertex, the rod starts at vertex, right? So this is your vertex, and then this is the conducting wires, and then the rod has moved by some distance in 1 second. So every particular data has some value when you try to solve the questions, right? So very good question if you're preparing for JEE mains or West Bengal JEE, or any other examination. This actually helps you increase your conceptual knowledge. So I've done it in steps so that you also learn how to tackle problems. I have not just done a simple solution, but tried hard to make you explain this. So I'm giving you a link below where I am putting my blogs as to how to solve the physics problem, how to handle Newton's third law, stuff like that. So please subscribe to this blog also, and you will see some fantastic ideas, and you can give comments also what topics you would like to cover. So I hope you enjoyed this video, you liked it, and please do share it with your friends, in your family, and give your comments in the comment section in the YouTube also. Thank you very much for your time, and wait for my next video.